Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This is a multi-step organic synthesis problem involving nucleophilic substitution, hydrolysis, and esterification. Moving on to the next step. First reaction, CH3CH to CH2Br plus NaCN(X1) bromopropane undergoes SN2 reaction with sodium cyanide, NaCN, as a nucleophile. The cyanide ion displaces the bromide, giving CH3CH to CH2CN butanitrile. So X is equal to CH3CH to CH2CN. Moving on to the next step. Second reaction, X plus H3O plus heat Y the nitrile, CH3CH to CH2CN undergoes acid-catalyzed hydrolysis under aqueous acidic conditions with heat. Nitriles hydrolyze to carboxylic acids under these conditions, CH3CH to CH2CN plus H3O plus heat CH3CH to CH2Q, butanoic acid. So Y is equal to CH3CH to CH2Q. And for the final step. Third reaction, Y plus CH3CH to H plus Z butanoic acid reacts with ethanol, CH3CH2O, in the presence of an acid catalyst, H+, in a Fischer esterification. The carboxylic acid reacts with ethanol to form an ester, CH3CH to CH2Q plus CH3CH2O CH3CH to CH2Q to CH3 plus H2O. So Z is equal to CH3CH to CH2Q to CH3, ethyl butanoate. Z is equal to CH3CH to CH2C is equal to O, OCH to CH3, which corresponds to option D. Option A, CH3CH is equal to CHC is equal to O of is crotonic acid, which would require different starting conditions and an elimination step not present here. Option B, CH3CH to CH2CH is equal to notch to CH3 is an oxime ether, which would require reaction with a hydroxylamine derivative, not ethanol H+. Option C, CH3CH to CH2CH, OCH to CH3, 2 is an acetyl, which forms from an aldehyde with ethanol H+, not from a carboxylic acid. Option D correctly represents the ester product of butanoic acid with ethanol. Therefore, the correct answer is D. Therefore, the correct answer is option D.